Alaikum. I'll share with you our experience at KFMC. I'll focus on the practical aspects of prostate brachytherapy. First, I have no disclosures. Brachytherapy, most of us are familiar with the gynae brachytherapy. Prostate brachytherapy, not much different. The only major thing that all the loading, all the delivery will be through needles. So prostate brachytherapy is a fully interstitial process. You will need the same equipment. You will need an afterloader, and you will need your radioactive source to be calibrated and ready to be used. Then you can move to the next step of implementing your own prostate brachytherapy program. Sorry. I have bad tonsillitis, by the way, so if I hiccup, excuse me, please. So the aim of prostate brachytherapy is to deliver intense dose to the prostate gland. It's not tumor, it's not BTV, it's not GTV. It's highly visible. Thank you very much. It's highly visible organ. It's located anterior to the rectum and inferior to the bladder. And there is another organ of interest, organ of risk that goes through the prostate, which is the urethra. So we have to target the prostate itself and avoid these three. But from practice, you notice that it's only the urethra and the rectum that are, or actually the anterior wall of the rectum, that are of concern. To do that, we have to access the prostate through the perineum. There is no other easier way to do it. The way that we will visualize the prostate and see it is through transrectal ultrasound. The imaging modality is ultrasound. The equipment you need. Sorry, I'm having difficulty seeing this. How to? The equipment that we need is ultrasound machine. Everybody, I assume, any physicist in the field will be familiar with the ultrasound machine. We will need a biplane transducer, stabilizer, and a stepper mounted on the stabilizer, and a template to locate our needles. The ultrasound and the transducer for imaging. The stepper is to advance the probe inside the rectum and acquire the 3D images of the prostate, and the stabilizer to stabilize the stepper and make it easy to acquire the images and move it very accurately. The template is our coordinate system that will allow us to identify the needles and deliver the needles where we need them inside the prostate. There are two methods to distribute the needles. The first, that you distribute it uniformly around the volume itself of the prostate, then try to increase the dose within the prostate by introducing new needles. The advantage of this model that can be more uniform, or the dose will be more conformal to the easily more conformal to the prostate. The second method is to distribute the needles uniformly and let the planning system do the optimization for the needles. Each method has its own advantages and disadvantages, but I see the first one works most of the time much better than the other. To start training, the best method is to use the phantoms. There are many phantoms. One of them is the phantom I'm showing now. This mimics the prostate along with the rectum and the urethra, and also the seminal vesicles. And it gives very compelling images that you really will believe it is a real prostate. So the process itself starts by introducing the transrectal ultrasound into the rectum and acquiring an initial image to help with the pre-planning and assess the volume of the prostate. And we might also have other diagnostic imaging modality like MRI that we can register to this image to enhance the planning and target if there are nodes inside the prostate that we need to enhance. Then we acquire a 3D image using the stepper, just like a CT. We take a slice after slice to make the 3D image. Then we contour the prostate and the organs at risk. This is what will you see on the ultrasound machine. The template here will be projected over the image. That's what will allow you or help you direct the needles and locate them to avoid injuring the urethra or the rectum or the bladder. Once we've done that, we can start the planning, the initial plan, locating the positions that we want to load in, the needles in. Then we start introducing the needles inside the prostate. Once that's done, we can start the optimization on the planning system by finding the best distribution of time and dwelling positions that will deliver the required dose to the prostate, either if it is a single fraction Stingray or 2 fractions for salvage treatments. Then we have to realign the contours that we done earlier with the prostate. After introducing the needles, the prostate might shift or might change the shape a little bit. We have to revisit the contours and make sure it is still aligned, and pay a lot of attention to the needle alignment that we see on the planning system and on the ultrasound image. After developing the plan, it's just like any other radiotherapy plan. We assess the plan, see the dose distribution, see the DPH for all the organs at risk, and usually this takes between 20 to 30 minutes to do the planning and the insertion of the needles. Then the delivery comes after that. Basically, this is what I want to share with you. Thank you very much for your time. If no questions, I can move to the. Thank you.